Okay, so when we are talking about forming equations, if we're given a reaction, so a photosynthesis, we are talking about taking two reactants and turning it into two new products. Sorry. So really what you're looking at is almost a double replacement and a synthesis at the same time, because you're combining two things together, you're creating something else. But in this case, we have two products. So with photosynthesis, it says the process in which we have plants convert carbon dioxide into water, and it should say light as well, light energy, because you have to have the sun. And we turn that into carbohydrates and oxygen. So in this case, we're going to talk about creating glucose. So we have to know what glucose is. So since we've been talking about glucose a lot, you should know that it's C6H12O6. So we know that is what we have for our particular glucose molecule. We know that carbon dioxide is CO2, and we know that water is H2O. So the nice thing is this question basically sets it up for us. Now oxygen, we look at the periodic table, we know that oxygen is one of those diatomics. So it is O2 that we see it in nature. So we see it converts, so that's going to tell us that our reactants, so we're going to identify the reactants as these. So our reactants are going to be carbon dioxide and water. So we can actually start off with our CO2 plus H2O plus light. Now this is not necessary, but it gets you to understand that this is where the energy comes from to create our next thing. So remember, H2O is a liquid, CO2 is a gas. Now, this is where the tricky part comes. So when we have glucose, we have C6H12O6 is our product, and as well, our product is going to be oxygen as well. So we get our gas in oxygen, and this is going to be a solid, as in like the sugars from the plant. So it could either be a solid or a liquid, but we'll say it's solid. Or it could be aqueous, which is dissolved in water. But we're not going to have an aqueous for this particular one. So this is what it looks like. Pretty simple, right? Now it's not done because it needs to be balanced. Balancing is something that we'll do a lot more of as we go. But for practice, I want to show you what we do. So we see here we have C, O, and H on both sides. So we don't have anything else. So we'll put C, O, and H on both sides. So we have our reactants and our products. So we're going to put how many we see of each on here. So we have 3 O's, 1 C, and 2 H's on this side. And we have 6 C's, 12 H's, and 8 O's on this side. Now, best thing we can do is we can plug and try to do the carbon first so we can get to where we need to go. So we'll put a 6 in front of carbon to start. So that'll change this to 6. It'll change this oxygen to 13, but we're going to need 6 of these as well. So we have 6. So 12 plus 6 gives us 18. And we have our 12 here. So we have what we need for our carbons, we have what we need for our hydrogens. So what we will do now is we don't need to change anything to this glucose because we're going to get one molecule for that in this equation. But we need to balance our oxygens. So if we have 8 total, we have to get this one to 12 because we have 6 there, because we want to get it to 18. So 6 plus 12 gives us 18. So we'll just put a 6 in front of this, and that balances it out, because that gets us to our 18. Because 6 times 2 is 12, plus 6 is 18. So that's what we would do to balance out the photosynthesis equation. All right. Now, for the rest of it, all you're doing is identifying reactants, products, precipitants, things like that, and then you'll write out your base equation. I do not expect you to balance, but you are more than welcome to try to balance if you want to. I'm not going to be upset with that. The more balancing, the better. But we'll still have to get used to doing, like, writing out your equations, and then we will balance it out as we go. All right? That's all for today.